Hello dear viewers, you are most welcome to Ramsai Jared Academy, which is a chemistry YouTube channel where we share content of chemistry in terms of recorded videos of lessons, items of chemistry and their expected responses and past papers. So you are most welcome, and if you are new to the channel, you can subscribe to the channel for more updates. And now in this presentation, we have the item 2 of our scenario. Still, it is an item of chemistry. Last time we had the responses of item 001, and I hope we digested it very well and understood. So today, let us now have it worked out thoroughly. So let us go through it together and be attentive. So whenever you've got lost, you can just rewatch the video so that you can understand, and endeavor to watch up to the end for better understanding. Let us now dive in and start by reading the question. Weedmaster is a common herbicide used to kill weeds in Uganda. Its chemical, in brackets IUPAC, we saw the full name of this abbreviation. It is International Union of Pure and Applied Chemistry. So name is 3,6-dichloro-2-methoxybenzoic acid. Then this one is 2,4-dichlorophenoxacetic acid. Then N-methylomethanamine. Weedmaster consists of 45.1% carbon, 4.88% hydrogen, 26.7% chlorine, 5.3% nitrogen, and 18.05% oxygen. Then we have our tasks here, beginning with part A. Determine the Roman number 1. We have empirical formula of the Weedmaster, and in brackets here we've been given the RAM of the elements found in this Weedmaster. Then Roman number 2, we have determined the molecular mass of the Weedmaster, given the vapor density as 266. Roman number 3, or part A, we're going to determine still the molecular formula of the Weedmaster. Then part B, it reads the concentrated solution of Weedmaster packed in a 1 liter bottle is 20 moles per liter of solution. If the mixing ratio of Weedmaster to volume of water is 120 cubic centimeters to 20 liters of water to make spray solution, determine the number of, we have Roman number 1 or part B, mole used, this one should be moles, used to make up 20 liters of spray solution. Then Roman number 2 or part B, we have determined the number of grams used to make up 15 liters of spray solution. Then Roman number 3, we have determined the number of molecules of Weedmaster in 50 cubic centimeters of concentrated solution. In brackets, we have from the Avogadro's principle, 1 mole of a substance contains 6.02 exponent 23 particles. Then part C of our task reads, if 20 liters of spray solution can be used to spray an area of 25 yards squared, determine then, so we have Roman number 1 of part C, volume of Weedmaster, in brackets bottled, required for spraying an area of 8,000 square yards. Then Roman number 2 of part C, we have determined the number of bottles required by the farmer to spray an area of 8,000 square yards. Then Roman number 3 of our part C, we have determined the number of moles of Weedmaster in the bottles in C1 above. This one is a reference. Then Roman number 5 and the last one of part C, we have determined the number of grams of Weedmaster in the bottles in C2 above. The reference is Roman number 2. So now you're welcome. Let us have a dive in into the solution and we digest whichever is in this scenario or this chemistry question. So now let us have the written response in here, step by step, and let us follow. So this is our response. Let me use blue, and we are beginning answering this item with part A. So as we revised the question, the part A is like determine the empirical formula of Weedmaster, and we've been given in here the compositions by percentage of the elements present in this Weedmaster. So being given here, we have 45.1% carbon, 4.88% hydrogen, 26.7% chlorine, 5.3% nitrogen, and 18.05% oxygen. So what we have to do first to add up with this to see whether they will be equal to 100. So let me first do that. So when I sum them, I see that I'm getting 100.03% when I sum all these compositions, and I can see it is relatively nearest to or approximately to 100. So we can now proceed with our question. Part A of determining the empirical formula of the Weedmaster. So we have the elements present and by composition. So we are going to begin by writing the elements present in the Weedmaster. So this is what I'm meaning. We have now the elements present. So elements present, we have carbon, we have hydrogen, we have chlorine, we have nitrogen, and then oxygen. So the order it may not matter a lot since you are just getting the empirical formula. Then from here, since we are determining the empirical formula, we need to analyze or take a note of the percentage composition by mass. So for carbon, we've been told that it is 45.1%. Hydrogen, it is 4.88%. Then chlorine, it is 25.7. Nitrogen is 5.3. This is 5.3. And then oxygen, we've been told it is 18.05. So having written the percentage composition of the elements present in the Weedmaster, the next step here we have to get number of moles. So number of moles. And how do we get number of moles? The number of moles are got by dividing the given mass of a substance by the RAM of that substance. So in here, since these are the elements, we are going to get the mass divided by the RAM of each and every element in here. So remember now this question is coming from the topic we know very well, and I'm not mentioning it. You can now think of it and drop a message in the comment section below. So which topic do you think this item is coming from? So as we proceed to get the number of moles, simply we are going to get the 45.1 divided by the RAM of carbon is 12. So this one is going to give us the answer as we press the calculator. Let us first write them. So for hydrogen we have 4.88 divided by the RAM of hydrogen is 1. Chlorine, it is 25.7 divided by the RAM of chlorine is 35.5. Then nitrogen, we have it as the 5.3 divided by the RAM of nitrogen is 14. Then lastly oxygen, we have it as 18.05 divided by the RAM of oxygen, which is 16. So as I press the calculator for carbon, I'm getting the number of moles to be 3.75. So now I'm rounding off to, let me use a different ink so that I can distinguish these figures. So let me use green for the answer I'm getting. So in here I'm getting the 3.76. I've rounded off to 2 dp. So let us keep it constant. We keep rounding off to 2 dp. So this one remains this 4.88. Then for chlorine, as I divide, I'm getting 0.75. Then for nitrogen, I'm getting 0.38. Whereas for oxygen, I'm getting 1.13. So having got the number of moles, our next step, we are going to get the mole ratios. In here for carbon, I have 3.76. For hydrogen, I have the 4.88. For chlorine, I have the 0.75. The nitrogen, I have it as 0.38. Then oxygen, I have it as 1.13. So remember, we are getting the mole ratios, so we need to include these ratios. It shows that we are getting the ratios, and then we have to divide it through by the smallest. The smallest here is now 0.38. So divided by the 0.38, divided by the 0.38. So as we divide in here, we are getting the answer. Let us round off to still 2dp. So this is now 9.87 to 12.84 to 1.97 to 1 to 2.97. Then we need to get the simplest mole ratio or mole ratios. So in here we need to now to make them whole numbers. So in here this one is approximately equal to 10. This one is around 13. Then this one is around 2. This is remaining 1. And then this is around 3. So these are now the mole ratios or the simplest mole ratios. Remember, they want us to get the empirical formula. So we can now go ahead and deduce that now, therefore, the empirical formula of the Weedmaster is, we now substitute in, remember, the 10 is for carbon, so we have C10. Then the next one is for hydrogen. You can cross check, it's for hydrogen. So hydrogen, but how many? 13. Then the next one is chlorine, so we have chlorine, and there are 2, followed by nitrogen, and it's only 1. Then lastly oxygen, and there are 3. So this becomes now our empirical formula. That is part A, Roman number 1. We can now proceed to part A, Roman number 2, which requires us to get the molar mass given the vapor density as 266. So this is Roman number 2 of our part A. We have to get the molecular mass. So we've been given the vapor density as 266. They want us to get the molecular mass, but we know very well that from this formula that the molecular mass equals to twice the vapor density. So we are going to use this relationship and get the answer. So in here, we are going to just simply get 2 multiplied by the vapor density, which is 266. As I press the calculator here, I'm getting the value to be the 532. We can now conclude that therefore the molecular mass of the Weedmaster is 532 grams. So that is for Roman number 2 of our part A. Then Roman number 3 of part A is like determine the molecular formula of Weedmaster. So we need to go ahead and determine the molecular formula of the Weedmaster, having got the molecular mass. So we have now our part A, Roman number 3. They want us to get the molecular formula. So in here, this is what we are going to say, that from this relationship, that mass of empirical formula multiplied by n should be equal to the molecular mass or the molar mass. What does it mean? Remember, our empirical formula is, the empirical formula is given as the C10H, let me cross check. So H13, chlorine 2, nitrogen 1, and then oxygen 3. So this is our empirical formula. Then we need to get the mass of the empirical formula. To get the mass of the empirical formula, we are now going to have the bracket in here. Then we are going to have 10. There are 10 of carbon multiplied by the ram of carbon, which is 12, plus, for now, hydrogen, we have 13 atoms multiplied by the ram of hydrogen, which is 1, plus chlorine, we have 2 atoms of chlorine multiplied by the ram of chlorine, which is 35.5. Then plus nitrogen, we have 1 atom multiplied by the ram of nitrogen, which is 14, plus for oxygen, we have 3 atoms multiplied by the ram of oxygen, which is 16. So the whole of this is multiplied by n, then should be equal to our molecular mass, which is 532. So as we simplify here, we can see that if you multiply this is 120 plus 13 plus 71 plus 14 plus 48, close the brackets, multiplied by n should be equal to 532. So if I press the calculator here, I'm getting the sum here to be 266 multiplied by n, so to be 266n equals to the 532. So from here we need to look for the value of n simply by dividing through the 266. So our value of n is going to be equal to the 532 divided by the 266. So n is equal to 2. So having got the value of n as being 2, then we are going to have now the molecular formula being equal to, we have now the empirical formula in brackets here, which is the C10H13, chlorine 2, nitrogen 1, oxygen 3, multiplied by n. So remember n is equal to 2. That means multiplied by the 2. Simply in here, the molecular formula is coming to be the C20, carbon 20, H, so we have 13 multiplied by 2, this is 26, then chlorine, we have 2 multiplied by 2 to give us the 4, then nitrogen, we have now the 2, oxygen becoming 6. We can now go ahead and conclude in our question. Remember, we have to conclude. It's very, very important. So therefore, the molecular formula of the Weedmaster is C20, hydrogen 26, chlorine 4 of them, nitrogen 2, then oxygen 6. So this becomes our correct answer for Roman numeral 3 of part A. We can now proceed with the question. Now going to part B of our question. So that the concentrated solution of Weedmaster packed in one bottle, in 1 liter bottle, is 20 moles per liter of solution. So this is molarity. Whenever they say 20 moles per liter of solution, that is already molarity per liter. There are 20 moles in 1,000 cubic centimeters. So if the mixing ratio of Weedmaster to volume of water is 120 cubic centimeters to 20 liters of water to make spray solution, determine the number of moles used to make up 20 liters of spray solution. So that is Roman number 1 of part B, to make 20 liters of spray solution. So in here from molarity, since we discovered that the other one was molarity, we are going to say that the 1,000 cubic centimeters of solution, which solution of Weedmaster, contain 20 moles. So that is from the other question. So if 1,000 cubic centimeters contain these moles, what about 1 cubic centimeters of still solution contain, we're going to have the 20 divided by 1,000, and still this gives us in terms of moles. So what about now the 120 cubic centimeters? Because they said 120 cubic centimeters of the concentrated solution or concentrated Weedmaster is needed to make 20 liters. So we say that what about 120 cubic centimeters of solution would contain how many moles? Simply get the 20 divided by 1,000 multiplied by the 120, and this is still going to be moles. So having got that, if I press the calculator here, I'm getting my answer to be 2.4 moles. We can now conclude by revisiting the question. Part B, moles used to make up 20 liters of spray solution. We can now say that therefore 2.4 moles of Weedmaster is required to make the 20 liters of spray solution. So this becomes the answer for Roman numeral 1 of part B. Then we can proceed to Roman numeral 2 of our part B. So this is part B, Roman numeral 2. What does it want us to calculate? So that determine the grams used to make up 15 liters of spray solution. Remember they told us 120 cubic centimeters of concentrated Weedmaster solution requires us to make the 20 liters of the spray solution. Then let us first get the number of moles required to make the 15 liters of spray solution. Then thereafter we shall use it to determine its mass. This is what I'm meaning. We can now begin from this point that if the 2.4 moles of Weedmaster make 20 liters of solution, which kind of solution? Spray solution. Then what about now? We look for what about 15. So this, remember, what we are looking for the number of moles required to make the 15 liters of spray solution. So we can reverse this statement that this is the same thing as saying that 20 liters of spray solution requires 2.4 moles. Then what about 15? Because they are talking of 15 liters. What about 15 liters? So 15 liters of a spray solution would require, so simply we're going to get 2.4 divided by the 20, then multiplied by the 15 liters. And still we have it as moles. In here, the answer I'm getting is coming to be 1.8 moles. So having got those moles, remember they're asking for the mass, then we need to go ahead and calculate the mass. So we can say that from 1 mole of Weedmaster weigh, so weigh what? Which grams? Weigh, this is now the mass, molecular mass, weigh 532 grams. What about these moles? So what about the 1.8 moles of steel Weedmaster would weigh, simply we're going to multiply, so would weigh 1.8 multiplied by the 532, and see this one is going to be in grams. So when I compute this, I'm getting my value to be 957.6, and this one is correct, 1 dp. So this is the mass I'm getting. So therefore we need to conclude for this part that now therefore 957.6 grams of Weedmaster is required to make 15 liters of spray solution. So this becomes our correct answer for part B, Roman numeral 2. Then let's proceed to part B, Roman numeral 3. It reads, we are determining the molecules of Weedmaster in 50 cubic centimeters of constant solution. Remember the Avogadro's number is here, so we have to go in for that. This is Roman numeral 3 of part B. Remember they told us that from the scenario that 1,000 cubic centimeters of Weedmaster contain how many moles? Contain 20 moles. What about 1 cubic centimeters of steel, our Weedmaster? So contain, simply we're going to divide. So we have 20 divided by the 1,000, and still this multiplied by 1. This is still in moles. So what about the 50 cubic centimeters of steel, the Weedmaster? So this one would contain, simply we're going to get the 20 divided by the 1,000 multiplied by the 50, and see this side we are going to get as moles. So as I press the calculator, I'm getting the value to be 1 mole. And remember they're asking for the number of molecules, and since for 1 mole, and remember from Avogadro's constant or number, it says that 1 mole of a substance contains 6.02 exponent 23 particles, and these particles can be molecules, atoms, electrons, ions. But it's specified for that part, for this part, which is part B, Roman numeral 3, requires us to get the number of molecules. And since it is 1 mole, simply it is equivalent to the Avogadro's number. Therefore, we are going to say that therefore 50 cubic centimeters of the Weedmaster contain how many molecules? Contain 6.02 exponent 23 molecules. Why? Because we have got 1 mole. Therefore, this becomes our correct answer for Roman numeral 3 of part B. So we need to proceed to part C of our question. It reads, if 20 liters of spray solution can be used to spray an area of 25 yards squared, then we have Roman number 1, determine the volume of Weedmaster bottled required for spraying an area of 8,000 square yards. So this is part C, Roman numeral 1. Remember they have told us that 20 liters of spray solution work on 25 yards squared. And since you want to get the number of liters, so what we are going to do, we are going to reverse this statement. So it's the same as saying that 25 yards squared require 20 liters of Cypre solution. Then what about the 8,000 yards squared? So we would require, we are going to get the 20 divided by the 25, then multiplied by the 8,000. And still this is going to be in liters. When I press the calculator, I'm getting the value to be 6,400 liters. So these are now the number of liters of the Cypre solution required to Cypre the 8,000 square yards. But remember, they want us to get the volume of the bottled Weedmaster required to make the Cypre solution of this volume. So that means here we have to proceed and say that still 20 liters of our Cypre solution was made by using the 120 cubic centimeters of bottled Weedmaster or bottled Weedmaster. Then what about this volume? What about the 6,400 liters of still our Cypre solution was made or can be made by using now the 120 divided by the 20 multiplied by the 6,400. So in here, see, we are going to get the volume. So when I compute this, I'm getting my answer to be 38,400 cubic centimeters. So this is now the volume of the concentrated Weedmaster required. That means from here we can now go ahead and conclude that therefore 38,400 cubic centimeters of concentrated Weedmaster is required to make a Cypre solution to Cypre the 8,000 yards squared. So this becomes our response for part C Roman numeral 1. Then part C Roman numeral 2, it says that determine the number of bottles required by the farmer to spray an area of 8,000 square yards. So this time round they want the bottles. But remember, they say that one bottle is of 1 liter. One bottle of concentrated Weedmaster. So this is part C, Roman numeral 2. This is what we are going to do. That 1,000 cubic centimeters of the concentrated Weedmaster is contained in one bottle. So in one bottle we have 1,000 cubic centimeters. What about when it is 1 cubic centimeter? Still of conch Weedmaster is contained in, so this is 1 divided by 1,000 and still gonna be the number of bottles. So now what about the volume? The volume which is required is the 38,400 cubic centimeters of the conch Weedmaster is contained in, so simply we are going to get this multiplied by the 38,400. So when I compute in here, I'm getting the 38.4 bottles. So this is approximately the 39 bottles. We can now conclude, because they asked us to get the number of bottles required. You can say that therefore approximately 39 bottles are required to spray an area of 8,000 yards squared. So this becomes the answer for Roman numeral 2 of part C. Then Roman numeral 3 of part C, it requires us to determine the number of moles of Weedmaster in the bottle in C1 above. So in C1 above. So this is what we are going to do. This is C, Roman numeral 3. From 1,000 cubic centimeters of a Weedmaster, but concentrated, we say it contains 20 moles. That is from right. What about now the 1 cubic centimeter of the Weedmaster contain the 20 divided by the 1,000 multiplied by 1, and see these are moles. So then what about the volume here which is required? It was the 38,400 cubic centimeters of the Weedmaster contain, so we have now the 20 divided by the 1,000 multiplied by the 38,400. So these are moles, and if I compute, I'm getting 768 moles. I can now conclude that therefore 768 moles are required. That is Roman numeral 3 of part C. You can now go to the last Roman numeral, that is Roman numeral 4 of our question, which is the last one. It requires to determine the number of grams of Weed Master in the bottle in C2 above. So Roman numeral 2 of part C is our reference point. That means we are going to say that this is Roman numeral 4 of part C, that from 1 mole of our Weed Master weigh, so this is molar mass, weigh the 532 grams. What about now these moles? What about the 768 moles of still our Weed Master? This one would weigh, simply we are going to multiply, so we have the 532 multiplied by the 768, and these are going to be still grams. So as I multiply here, the calculator is giving me 408,576 grams. Therefore, 408,576 grams of Weed Master is required. So this marks our last part, and if this video has been of value or helped you, kindly subscribe to Ramsay Jared Academy for more videos of chemistry. See you again next time. Goodbye.